those that go with it. So we didn't finish 5.4 last time, so I had to redo it over here. I'm thinking 5.5, maybe 1 or 2 days, maybe, but maybe for sure review next week on the 15th and exam on the 17th. That'll be a little doable that way here. So homework 5.3 due tonight. 5.4 will be due on Wednesday here. So let's tackle some homework questions and we'll keep on going. Are we good? Boom. And so let me scroll to the end here to do that. All right, all yours.
17, 41, and 49.
Okay. 5.3, 17, 21. What else?
9,
Number 9,
41,
41,
and 49.
49,
Yeah, you guys read on.
45. Uh-huh.
Would say all of them.
53.
53,
And then 61.
61. Okay. Let's jam. Okay, ready?
Yeah.
That's a lot. So let's go with it really quick here. 5.3, is that correct? Okay, number 9. Let's start with number 9. Number 9 says tangent theta is equal to 5/12. Is that it right here? It is in quadrant 1. That's cool. Find for me sine 2 theta. So real quick here, sine 2 theta would be 2 sine theta cosine theta as the formula goes. But we only have tangent. So as we set this up in quadrant 1, we're going to know that the opposite side is 5. The adjacent side is 12. We're good there? What is the hypotenuse? Anyone? 13?
That triangle a lot, so
Say again?
we use that triangle a lot.
Uh-huh.
I have 12 and 13.
13, okay. Perfect. Right there. Pythagorean theorem if you need to here, but then we're done. So then we just need to plug in the values here. So 2 sine is going to be opposite over hypotenuse. Cosine will be adjacent over hypotenuse. And then the rest of it is just a multiplier across. We're good? So that's 10, 120 over 169, I believe. Yes, no, maybe? I'll take it as a yes. Number 17, let's see if I can put it down here. Graph each of the following from 0 to 2 pi. Okie dokie. I have 4 minus 8 sine squared theta. So question is, does that fit any one of our formulas? You know what, if I were to factor out a 4 out of this, if I do this, it should become that right there, and anybody for this guy. What does that equal? Cosine 2x, right? Double angle formula for cosine. Perfecto. Think I'm ready for graphing because that's something I can do really, really good. So 0 to 2 pi. There's pi over 2. And then I'm going to go with amplitude. AMP, amplitude is 4. That's that guy over here. Absolute value of that guy, actually. And period. Period is 2 pi divided by this little guy right there. So my period is pi, and that's all I need to worry about. So that means I do need to cut this little pi right here in 4 pieces. So that means this has to be pi over 4. This is pi over 2 pi over 4, 3 pi over 4, and 4 pi over 4. I cut into 4 pieces. I go 1, 2, 3, 4, 1, 2, 3, 4. Cosine is going to start high all the way up at 4. Come all the way down to -4. Go all the way up. And then we're going to do it again. So hold on. I cut this into pi over 4s. I think I can do this. Pi over 4, 3, 2 pi over 4, 3 pi over 4, 4 pi over 4. This will be 5 pi over 4, 6 pi over 4, 3 pi over 2. Perfect. 7 pi over 4 will be right here. That should be 8 pi over 4. Perfect. So then I'm going to go down again. Hit that right there. Come back up, and I should have that little graph there. Everybody good with that? Sweet. Sure. No problem. This is for you guys, so tell me, go slower anytime. I'm just wondering what you guys got caught on. Let's see, the proving the identity stuff, was that the toughy ones? Sort of. Cool. Okay, 21. 21, now let's graph this guy. 1 minus 2 sine squared 2x. Oh, that's no fun. Very similar like the last one. I know it's gonna be cosine. Cosine of 2, but it's a 2x. Are we okay there? So it's going to be cosine of 4x. Still graphing from 0 to 2 pi. Oh man, this is going to be going very fast up and down here. So let me do the amplitude. Amplitude is 1. That's easy enough. The period is our little problem right here. Period is going to be 2 pi divided by 4 this time. So pi over 2. Whoa, crazy. So up until here, we're gonna have to do a whole cycle for cosine. So half of pi over 4 is pi over 4, half of pi over 2 is pi over 4, half of that is pi over 8. So we're gonna do everything in terms of pi over 8, all the way over to 2 pi. All right, here we go. Pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, which is the same thing as 3/4 pi. 7 pi over 8, 8 pi over 8 is here. And 9 pi over 8. 10 pi over 8 would be that one. 11 pi over 8. 12 pi over 8. 13, 14, 15. Messing it up. It's not a nice little standard there. Let's see, can I do it again real quick here? I'm gonna divide so I get all the middles taken care of here. Hold on. So this guy here, the middle between pi and 2 pi would be 3 pi over 2, is that right? The middle here. Let's see, pi over 4, 5 pi over 4. This is 6 pi over 4, 7 pi over 4. And then I can put in the 8s in here. There, that's a little bit better. We're good. I don't even need to tell it what it is, as long as I have the tick marks there. So here it is. Need to do one full revolution here. I would make this a little bit bigger. I'm going to go from 1 to -1. All right, here we go. Going down to -1, going up. Right there. 2, 3, 4. Are we good? It almost reached down to -1 each time. But there should be 4 full cycles here as we get to 2 pi. Okay, are we good there? Let's go 21, 41 now. Okay, tell me when you're done. Tell me when you guys are good to go. 41. All right, on these guys, it may be that you're just going to go one direction, and as you realize you're going to go one direction, you're like, oh, you know what, that's not going to go well. So then you just change it up, do a different thing, keep on going. And so cotangent is same thing as cosine over sine. I got that. That is the most simplified version. I probably don't need to go any more than that. On this side, I'm going to change it to from double angle to regular angle formula. Okay, so somehow I got to get rid of 2. And somehow I'm left over with the sign on the bottom. So somehow the 2 is going to disappear from the top. And the sign is going to disappear from the top. These guys have to get rid of somehow. All right, any guesses?
For cosine 2 theta, you can do 1 minus 1 minus sine. I mean, yeah, 1 minus.
I think it's 1 minus 2, right?
Yes.
Sine squared theta. It's that one there. Thinking I probably need a sign on the bottom in order to get rid of stuff. So just this piece alone, I plug in, it'll be 1 minus a 1 minus 2 sine squared theta. That's the little plug-in. Oh, and I think I'm headed in the right direction. 1, let's see, this one minus a minus 1. This would be plus 2 sine squared theta. Love it. That goes away. And the 2's are gone. Sine is reduced. And I got what I wanted in the first place. Write the left side as well. And today, I'm okay with QED today. Just takes a little while, sort of thing. And if you see that you're going off the wrong direction, that's okay. Just kind of turn back, start over. Have the, maybe print out this little back page, or at least the front page, and just have it open because you want to see all your identities, all your possible identities that you can put in. That'd be the easiest way to do it. Okay, good. 49? Nope. Yep, sure, absolutely. Ding, ding, ding. 49.
Wait, can we do 45?
45. 45 is the new 49. Oh, triple angle. Isn't that fun? Just love it. Minus 4 sine cubed theta. There it is. Okay, so we talked about double angle formulas. Now let's talk about triple angle formulas. And yep, you can do the same thing. Quadruple, quintuple, whatever you like. It just keeps on going and going. What else keeps on going and going? Life does. I thought the Energizer Bunny. Did they always say Energizer Bunny? Homework assignments, yes.
Oh, like homework assignments keep on going.
Going
and
and
going.
going.
I thought you said that's your homework assignment. I was like, wait, what?
All right, so let's see how we can do this here. Let's see, triple angle. She whiz. Oh, you know what? How about this? How about sine is really just that guy? Can that possibly do it? And then we might have to reduce it still some more. So, because notice on the right-hand side, all the thetas in terms of just theta, right? It's just sine theta and sine cubed theta. That's it. They're all in a single angle formula. So let's do this here. You remember the addition formula for sine.
Isn't it like 2 sine A sine B plus sine?
Oh, no, wait, that's multiplication.
No, addition formula. Not the double.
Sine A cosine B plus cosine A sine B.
Okay, sine A cosine B plus cosine A sine B. Oh yeah, I think we're getting somewhere.
Wait, but where does the 2 go?
So 2 theta acts as B.
2 theta acts as the B. Yeah. So
Oh.
theta by itself is A. Okay. So now that cosine 2 theta, that's my little problem. Is kind of like, how am I going to do that? How should I do that? I noticed that everything's in terms of sine. Okay, so that gives me a clue. That means I'm going to use this little formula. I'm going to use a 1 minus 2 sine squared theta for cosine. Oh, this cosine is just here. That's interesting. Let's see what happens here. And this is going to be 2 sine theta cosine theta. All right, let me multiply the sine or distribute the sine theta in here. And this is going to be 2 sine theta cosine. Oh, there it is, cosine squared theta. That's how I get rid of that cosine squared. I think I have a Pythagorean theorem on my hand somewhere. This would be 2 sine theta, and this would be, Pythagorean theorem says cosine squared theta is 1 minus sine squared theta. Crazy identity, but I think we got it. So this is sine theta minus 2 sine squared theta. This is going to be distributed to here, so it's 2, just 2 theta. And then this will be distributed to here, so there'll be minus 2 sine cubed theta. Oh, sorry. Class real quick here, sorry. When I distributed from here to here, that should have been a cubed theta coming all the way down. Sorry, those are the, with pens. Totally sorry. But I think we have 3 sine theta minus 4 sine cubed theta. Boom, boom, boom. That's awesome. That was a cool one. Finally a cool one. All right, good. Keep on going. Tell me if you need more time.
So,
Okay, no problem. Like I said, this is for you guys. Okay, 49. Let's see, cotangent theta minus tangent theta is equal to, oh, there's my cosine 2 theta again. Don't like it too much. I gotta decide which way to go. Okay, cosine 2 theta. I'm thinking maybe I'm gonna wait on that one for a little bit. I'm gonna see what cotangent and tangent are gonna give me at the end here. Maybe that will be enough for me to tell. So cotangent is cosine over sine. Tangent is sine over cosine, and I think I got what I needed. I'm gonna get common denominators here. So I got cosine theta, sine theta times cosine theta. Oh, that was easy. That means I'm gonna multiply this guy by cosine theta, which gives me cosine squared theta. This one I'm gonna multiply by sine theta, which gives me that right there. And voila, I think I'm almost done. That is an identity, is that right? So then I can make it just like this. Ta-da. Sweet, I like that one too. Going up real quick here, we're in 5361.
Could you go back to the one we were just at?
Uh-huh. Awesome. All right, 53. 1 minus tangent x plus tangent x. Dun, 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 dun. 1 minus sine 2x and cosine 2x. Okay. That is interesting. Okay. Let me start with tangent. Let's see what happens here. So let's do this one right here. This is going to be 1 minus sine x over cosine x. This will be 1 plus sine x over cosine x. I'm going to keep on going. This would be common denominator then. Let's see if I can do a couple steps here. Let's see. I'm going to get common denominators of cosine, and I'm going to put them together here. This would be cosine x minus sine x. Everybody okay with those? Those kind of 2 steps real quickly here.
Oh, so you just put the one into.
I got common denominators real quick here, and then I put them together. So this was, made this guy into a cosine x, added them together. Or combine them, actually, I should say. Same thing I'm going to do over here. Make this to 1 over 1. Cosine x, add together gets me, this gives me a cosine x, and this would be a cosine x plus sine x. All right, think back to your pre-algebra days here. If I have like a 5 over 4 divided by 3 over 4, if my 2 denominators are exactly the same, I change this guy to a multiplication. Remember, I have to take the reciprocal of this guy, right? So notice what happens is the 4s will cancel, and you're left with 5 over 3, which really just was the numerator on top and denominator on the bottom. We good? So common denominators means I can just cross these out. And I got myself cosine x minus sine x over cosine x plus sine x. Oh boy. And this 153 is an identity, right? Yeah, it says it's an identity. Okay, that's pretty simple right there on the left. So let's go back now to the right. So these guys are double angles right over here. So I'm gonna have to do something with them for sure, but sine, let me just kind of think about this here just for a little bit. I know I'm gonna have that right there, right? Oh, you know what? Now that I'm thinking about it, let's see, I have these different choices, right? For cosine. And maybe I did go the wrong way, because check this out. If I do 1 minus 2 sine squared x Is that the formula for it? Is that right? No, it would have been a 4 in there. Cosine 2x. Let me check something. It may be not. Let's see. 1 minus. I'm kind of stuck. Anybody got it? Or are we all stuck on it?
Could you use the sines or the cosine squared one minus one squared?
Let's try. Yeah, let's go that direction. Let's see what happens here.
I
So
didn't get it, so I don't know. But
maybe cosine squared A minus sine squared A.
I looked at that website you gave us and it has you do like both sides, I think. No, it had me do just the left side.
Left side only.
You turn cosine squared A into 1 minus sine. Actually, maybe that would be
We can go from both sides as well. That's fine too. How about this? So cosine, 'tis true. Everybody agreed that that is true? So far, so good. So how about if I do this here? How about if I go back over here? Maybe I went the wrong direction. And then I multiply in order to give me that denominator to be the same. So maybe on this side I should multiply. I'm going to multiply this denominator to by cosine x minus sine x. And the reason why I'm doing it is because I know once I multiply these guys together, I will get this right here. Good there. So let's do that. Cosine times cosine. This is the denominator part. This would be cosine squared x. The middles are going to cancel because they're a difference of 2 squares. Everybody good there? And then at the end, we're going to get sine squared x. And my denominator looks exactly how I want it. That is nice. Love it. On top, I have this to deal with now. So cosine times cosine is cosine squared x. This would be a minus sine x cosine x. This would be another minus sine x cosine x.
would it be minus 2 sine x, please? I mean, right?
Talk to me. Go ahead, Corinna.
Like cosine squared x minus 2 sine x.
Oh, you could, yeah. I'm just writing it out piece by piece.
Oh, I see.
So this is just this multiplication. It's just the outside multiplication of FOIL. Inside multiplication and the last ones here, it'll be a minus sine squared x. Oh, plus. That's right, because they're pluses. By golly, I think we got it. What's going to happen is this cosine squared x, sine squared x, that's going to turn into a 1. And in the middle 2 sections are going to turn into a minus 2 sine x cosine x. Are we good? Want me to write the last bit? Or are you guys okay finishing up?
I can't really read this.
Oh, sure, sure.
Already done there.
Sure. Let's do this here first.
Wait, so cosine squared x plus sine squared x.
That's pretty loud.
You're turning into 1.
Nicholas, if that happens again, you can close that window. Greta?
So cosine squared x plus sine squared x, you're turning into 1.
To the 1, And that gives you that little 1 right here on this side. That was a tricky one. Sure, yeah, close it up. Just okay.
They persist.
Okay, are we good? Need for me to finish it up, or are you guys okay finishing up? Okay, let's go. Next page would be, so these two would make a 1. That's a 1. The denominators are exactly how I want them. So that's with 1. This is a minus sine x, which is minus 2 sine x. So essentially you get 1 minus 2 sine x cosine x on top, and you got what you needed. And those two sides are now exactly the same. Voila. Cool. Okay. And 61, is it? Is that what we got?
Yes.
61. Uh, 61, is that honors or is that regular? Okay. Okay, just wondering here. Five tangent theta? 5 tangent theta, You good?
Wait, so it's 5 tan what we're trying to prove, and then that's the way we're trying to prove it.
We're trying to get everything in terms of x. So this, we should not have any thetas inside it whatsoever. We should have only x's inside there. So let's go for it here. So first things first, we're going to solve this for x. So divide by 5. Take the tangent inverse of it. So this becomes, so now theta is equal to tangent inverse of x over 5. Okay, we good there. Next is we're going to create our little angle measurement here. So if that is the case, and so we're going to use this little piece right here first for our triangle. So if tangent of theta is x over 5, that means opposite is x, adjacent is 5. We're good there? And then what we're going to do is we're going to get our middle. So our c value or r value, however you want to do it, it's going to be x squared plus 5 squared is equal to r squared in this case. And r is always positive anyways, so we get our r value here. So this little guy is x squared plus 25 with the square root on top. Very good so far.
Wait, so wouldn't it just be x plus 5?
Pythagorean theorem says you still have to take a square root of it, and then you have to square them first before you take the square root. Okay, so now let's deal with this little guy here now. So I got my references in case I need to use them. I'm not sure if I'm going to have to use them, but just in case I need to use them, I got them. Okay, so this guy, would be the same thing as, let's see if we can simplify it first. I guess we can just for a little bit here. Let's see if I need to. We could drop it in already. It just look a little bit more complicated. Let's do this here. Let's get rid of the, you have a half here, you have a 2 over here. Let's take out a 1/2 out of this. Actually, can I back up just a little bit here? Let's do this here. I'm sorry. I'm gonna go like this. I'm gonna go with 2 sine theta cosine theta. That'd be easier so that we don't have to do steps back. So here's what I'm looking at. I have a 2 theta on my hand, sine 2 theta, but my angle measurement is just in terms of theta alone. So if I were to plug in any trig functions here, I need to have it in terms of just theta, just a single value, not a double value. So simplifying sine 2 theta gives me this, which reduced gets me this right here. I could plug it in right here, except it's just a lot easier just to factor out the 1/2 already, since we already have all that. And now we can plug in stuff here. So this would be 1/2. Now theta by itself, we already have that identity right over here. Theta by itself is equal to tangent inverse of x over 5. Minus, and now let's deal with our sine functions here. Sine is opposite over the hypotenuse. Cosine is adjacent over hypotenuse. And we've got ourselves what, a 5x over x squared plus 25 at the end. Check something out real quickly here. Okay. And quick question is, Mr. NG, where's this ever going to be used? So you have, in generality here, you have a formula that's somehow in terms of theta. Could be that you're actually in polar coordinates. That's why. It could be that however you do the equation, you turn out to be in theta. So you're thinking about angle measurements of something. Could be the light of a lighthouse revolving around something like this. So that's generally, you have a lighthouse out here, you have land out here, and you have light that's going to the land, and it's circular motion. It's running around. So this could be the equation for it. And so instead of that, you want it in terms of just the x value, the length of the lighthouse from the land. Because then you can judge, as long as all the lighthouses are spinning the same, you can create a formula based upon just the length from the lighthouse to land, and you got what you need. So you're just trying to change it up. So you're changing it from one variable to another, so you can make a more standardized equation for something. That's kind of comes to mind, at least right now. And so this was a single, you captured a single lighthouse equation, and you notice that really it's the issue is the distance issue. It's not how fast it's spinning. Let's say all lighthouses spin exactly the same. And so voila, why not get it a formula? And now you have a generalized formula for every single lighthouse in the US that's spinning. Anyways, something like that. Okay.
So the 1/2 with the bottom equation, that's the final answer.
Final answer, That's now in terms of a totally different variable.
Wait, so the point of that was just to turn it into a different variable?
And let's see, in mathematics, what happens as well? Sometimes this might be an easier equation to deal with. Sometimes this might be. Call it, I think I remember the name. It's called isometric. Isometric calculations here. So what you do is you have variables down here. You change it to a different variable. You do all the work over here, and then you just change it right back to a different variable. Very common to do, especially if you have more rules doing it this way. In Algebra 2, you guys did something like that. If you guys did like the cube root of this multiplied by the cube root of something like that, maybe. You could do this in terms of radical form, right? And you multiply those guys together. Or you could change it to that's a different form, right? One's a radical form and one is actually a rational exponent form. And then you can do all the work in rational exponent and you bring it down to become radical form again. So kind of like the same thing here. You do it in a different way. Whew. Should we do one thing here? Let's do one thing here. We got to here. We got to here, is that right? Just one little itsy bitsy problem from here. We did sine, we did cosine. I think the formula for, oh, there it is. The formula for sine is this right here. Formula for cosine is this right here. And so we want to develop the formula for tangent. And then we can go on and we'll have all three formulas when we start on Wednesday here. So tangent, half angle formula for tangent. Well, let's do what we always did. We're going to make this one into a sine over cosine. And just see what happens. Let's see the top. And I'm going to flip to it here just to make sure. So I got the double angle, this half angle. Cosine or sine is 1 minus cosine A over 2. Cosine is 1 plus cosine A over 2. There's my little formulas. And let's use our algebra 2 techniques here. If you guys see a square root, 2 square roots, we can write them as a single square root, is that right? From algebra 2, it was something like this right here, like a square root of 2 and a square root of 3. You can write it as the square root of 2/3. So how about plus or minus this whole giant thing? And the 2's are gone, as we mentioned earlier, right? Denominators go away. Plus or minus 1 minus cosine A, 1 plus cosine A. All right, and that could have been the form if mathematicians just want to stay with it. Mathematicians, they don't want to stay with it. So what we do is we multiply in by 1, and the one that we want to multiply in is 1 plus cosine A, bless you. So we extend this out, and we multiply top and bottom by 1 plus cosine A. Technically, we're multiplying by 1, and we can do that anytime. Now, and we're running out of time. So let's do this here. On top, if I were to multiply this, difference of 2 squareds gets me 1 minus cosine squared A. On the bottom, that gets me 1 plus there's 2 of them. 2 of them exact same. Almost there, except I have to flip the slide here. All right, this guy, anybody? What is 1 minus cosine squared A gonna give us?
Sine squared A.
Sine squared A, I like that, okay. So the next one line down would be, square root of, plus or minus, sine squared A, 1 plus cosine A squared. Hey, aren't both those perfect squares? Yeah, they're perfect squares, okay. So how about, this becomes sine A, because now it gets out of the radical. This just becomes this. That's cool. That's a lot more simple. So hold on, the double angle formula or the half angle formula for tangent is just,
Wait, so what happened to the plus and minus?
gotcha, plus or minus. Let me think, it's not part of the formula here. Ding, 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 ding. Let me think on that. Because tangent does come from a different source as well. There's a different formula for it as well. But let me think how it disappears.
So, but in the final formula, it's not there.
Correct, Okay, and that's one formula. There's a second formula for tangent. Your little homework question for the day is, can you find the other one? Something about multiplying by a 1 in here somewhere. That caused this to be a little bit different. How about that? Give you a little mystery there. So I'll think about the plus and minus before Wednesday. We'll create the other formula for tangent, and then we'll finish up 5.4.
So the homework for 5.4 is due on Wednesday.
Correct, yeah, I'll move it.
Do this Wednesday?
It's not.
Not gonna be, I'm gonna change it up.
Yeah, my tenant community.
All right. It's time for the revolution.
Thank you.